Hi there, welcome to ReinardSynth lucky number 7. A sad, dirty RM1X Sequence Remixer on my bench, this time in search for some TLC. The front plate says in big letters Sequence Remixer, and I have no clue what it means. A beatbox then? Groove machine? Drum computer? Yeah. Anyway, I'm more of the tickling the ivories faction of musicians than the track muting, loop selecting, stop, button pressing remixer faction, and have little use for these machines, but they're still fun to play with and repair. For a contemporary review, again, I point you to a Bad Gear episode where Florian Peels, also from Vienna by the way, extols the virtues of the RM1X. This is the second RM1X I'm repairing, and the first one had a broken PCB which I craftily put together again with a lot of botch wires. Proud. But that's not the problem with this one. It, he or she, whatever, came to me dirty, lots of switches not working, and with a broken LCD, as the owner said. The backlight was on, the machine worked and played its patterns, but there was nothing to see on the display, and turning the contrast control knob did not change that. But with the highest contrast setting, after being on for a while, faintly, very faintly, I could see something on the display. And this is a clear indication that the LCD itself is working, but that there is something wrong with the contrast circuit. So I investigated that first. After fixing that, I turned my attention to the switches. I replaced them all, and the soft touch rubber dome switches are hard to get, by the way, but eventually I found a couple of them in Italy for a decent price. And last but not least, it's cleaning time again. Those buttons and pots were full of finger grease and sweat residue. Ugh. I will have a moment of zen for you with the button caps and knobs in the ultrasound cleaner, so stay tuned. So without further ado, let's get going. Oh, I forgot to mention, I will have a quick run through the ICs used in RM1X for your amusement. So interesting. The LCD is fed a negative bias voltage to set the LCD's contrast. And LCDs normally require a negative voltage for this, which is supplied by this circuit around the 5291 DC to DC converter, which is configured to generate from the +5 rail a negative voltage. This negative voltage generator is determined by VR1, the contrast control knob. Via some magic involving resistance ratios of R68, VR1, R60 and the ESR of C41, it should generate a negative voltage somewhere between -1.8 volt and -9 volt. And although not clearly visible in the schematics, it is buffered by C41 to smooth out any kind of ripple. But it only generates something between -6 and -1.8 volt, and -6 volt is not enough to have a clearly readable LCD. And as a hunch, I strongly suspected C41. So let's remove it from circuit and test if it's still good. Just a quick rundown of the chips used to make the RM1X work. Why? Because I can, and so I will. Let's start with the CPU section. The CPU itself is a 32-bit RISC processor made by Renesas and runs at 28.7 MHz, one instruction per clock cycle, it's RISC. And then moving on to the two 2 MB ROM chips, where the bottom one contains the OS and the top one the preset patterns. Not the sounds though, that will come later. Then we have 512 kilobytes of battery backed up RAM to store user patterns and songs, and here's the backup battery itself. And let's not forget the floppy disk controller, old style stuff. And last but not least, we have some buffer ICs, and there are also some on the reverse side of the PCB to read out the buttons and control the LEDs. Moving on to those chips related to the LCD, the negative voltage converter is on the top, and at the bottom we have the LCD controller and 32 kilobytes of display RAM to store the bitmap display contents. And then we arrive at the core of the sound generation of the RM1X, the SWX00B AWM2 based sound generator and effects DSP chip, a Yamaha in-house development. It also has its own CPU, but that is not used. It's purely used for sound generation, and as such it's a 32 voice XG chip, so nothing special. All the samples are stored in 8 megabytes of sound ROM, and I believe it stores the samples compressed with a 50% size reduction, which the SWX00B decompresses on the fly, so effectively it holds 16 megabytes of samples. Although I cannot confirm this though, the marketing material doesn't say anything about sample ROM size, but I expect this because of other chips Yamaha uses. Then there is 128 kilobytes of scratchpad RAM for the synth chip, used for effects and buffering, I believe. And last but not least, there's a 18-bit stereo digital to analog converter, which converts the serial digital audio output of the synth chip to an analog signal. So there you have it, the architecture of the RM1X. Any questions? Anyone? Bueller? Bueller?
1.